Morning students. The previous video we have seen shortest distance between parallel lines. Now we are going to see shortest distance between the two skew lines. Okay, so skew lines, how it should be? They are not intersecting and they are not parallel. So see that the theorem, the shortest distance between the two skew lines. See the equation, r vector is equal to a vector plus sb vector and r vector is equal to c vector plus td vector is given by, it is denoted as delta, or you can use d also, is equal to, it's a modulus of c vector minus a vector dot b vector cross d vector divided by modulus of b vector cross d vector. Okay, you see the skew lines equations, a vector plus sb vector and r vector is equal to c vector plus td vector. Okay, here your a vector and c vector are position vector of the passing point of the lines, and b vector and d vector are parallel vectors to the lines. See, we are going to find the shortest distance between two skew lines. Okay, see the diagram, L1 and L2, they are skew lines. So they are not parallel, they are not intersecting. So L1 passes through the point A whose position vector is a vector, and L1, the straight line, is parallel to b vector. So in the same way, L2 passes through the point C whose position vector is c vector, and your L2 is parallel to the vector d vector. So you are having a vector, c vector, they are the position vectors of the passing point of the line, and b vector, d vector are parallel vectors to the lines. Okay, you see now here your b vector and d vector, okay, they are parallel vectors. So if you write the cross product between b vector and d vector, that is b vector cross d vector, how it is? It is perpendicular to b vector and d vector. Okay, so see, now you are going to take SD. SD be the line segment which is perpendicular to both the lines L1 and L2. So let SD is the line segment, it is perpendicular to both the lines L1 and N2. Okay, so I have said your b vector cross d vector, how it is? It is perpendicular to b vector and d vector. Okay, so while you are comparing SD vector and your b vector cross d vector, how they are? They are parallel. Okay, so I have drawn here SD vector, this is, and b vector cross d vector is also acting in the same line. Okay, so now you are going to find the unit vector in the direction of SD vector. So which vector is acting in the direction of SD vector? B vector cross d vector. Now you are going to find the unit vector in the direction of SD vector. So it is nothing but unit vector. If you want to write, you have to write the vector which is divided by its modulus. So therefore your b vector cross d vector divided by whose modulus? What is it? Modulus of b vector cross d vector is a unit vector in the direction of SD vector. So now what is asked? Shortest distance between the skew lines. So the perpendicular vector SD vector, okay, that only whose modulus is represented the shortest distance between the two skew lines. But now what we have to find? We have to find modulus of SD vector. So the modulus of SD vector is nothing but the absolute value of the projection of AC vector on SD vector. So SD, this distance, this perpendicular distance to L1 and L2, that is the shortest distance. So how it will be find? It is modulus of SD vector is equal to, absolute value means it's a modulus. Modulus of the projection of AC vector on SD vector. See that? Modulus of SD vector is equal to modulus of projection of AC vector on SD vector. Okay. So projection of AC vector on SD vector is nothing but AC vector dot unit vector in the direction of SD vector. It's a formula to find the projection. Okay. So AC vector using position vector, how it will be written? OC vector minus OA vector. So what is OC vector? That is C vector. What is OA vector? A vector. So AC vector can be written as C vector minus A vector. Okay. Dot unit vector in the direction of SD vector. So which is the unit vector in the direction of SD vector? That is B vector cross D vector divided by modulus of B vector cross D vector. Okay, so whose absolute value is nothing but SD, that is the shortest distance between the two skew lines. Okay, so it will be written as modulus of C vector minus A vector dot B vector cross D vector divided by, it's a number. Okay, so it is a modulus of B vector cross D vector. So this is the shortest distance between two skew lines. Okay, so already we have seen the shortest distance between parallel lines. Now we have completed shortest distance between skew lines. Now we are moving to shortest distance between two intersecting lines. So the two intersecting lines intersect at a point. So at that point the distance is 0. So we can say shortest distance between two intersecting lines is 0. Okay, so you just take this distance, and when you equal to 0, so the denominator number which is equal to 0, so the numerator will become C vector minus A vector dot B vector cross D vector is equal to 0. This is the condition for the lines, two lines to intersect. What is it? C vector minus A vector dot B vector cross D vector is equal to 0. You look at this. Here how many vectors are involved? C vector minus A vector is a single vector, and B vector is a second vector. D vector is a third vector. Okay, you see that the first vector dot the cross product of the second and the third vector. This is nothing but a scalar triple product. The scalar triple product can be written as box product of C vector minus A vector, B vector, D vector. Okay, how to evaluate the box product? It is nothing but the determinant. Okay, so first vector, what is it? C vector minus A vector. Okay, so in the Cartesian form, how it will be written? A point is x1, y1, z1, and C point is x2, y2, z2 means you C vector minus A vector whose coordinates are x2 minus x1, y2 minus y1, z2 minus z1, and the B vector components b1, b2, b3. Third vector D vector components d1, d2, d3, which is equal to 0. Either you can use it in the vector form or you can use it in the Cartesian form. So this is the condition that the two straight lines to intersect. Okay, so see that here I have tabulated the shortest distance between intersecting lines, two parallel lines and two skew lines. So intersecting lines, the shortest distance is 0. Okay, come to the parallel lines. The parallel lines, if you want to use this formula, the line how it should be, you see the B vector, parallel vector of the first line and parallel vector of the second line should be same. B vector, here also B vector. But the scalar multiple can be different. Here I have used S, here it is given as T. So the parallel lines how it should be, R vector is equal to A vector plus SB vector. On the second line, R vector is equal to C vector plus T into B vector. Okay, the parallel lines should be like that. Then the shortest distance is, it's a modulus of C vector minus A vector cross B vector divided by modulus of B vector. And here your modulus of B vector should not be equal to 0 because it is in the denominator. And come to the skew lines. You see the equation how it should be. R vector is equal to A vector plus SB vector and R vector is equal to C vector plus TD vector. Here A, C, position vector of the passing point. B and D are parallel vector. So see the formula. D is equal to, it's a modulus of C vector minus A vector dot B vector cross D vector divided by modulus of B vector cross D vector. Or otherwise, you see the numerator, I have said it is a scalar triple product that can be written as a box product. So box product of C vector minus A vector, B vector, D vector. So absolute value, why it is so? Distance cannot be negative. So this box product may be negative, answer may come. So you have to take the absolute value of the box product of C vector minus A vector, B vector, D vector divided by modulus of B vector cross D vector, provided the denominator modulus of B vector cross D vector should not be equal to 0. This is the formula you should know to find the shortest distance between the lines. Okay, so using this we are coming to the exercise 6.5 first problem. Find the parametric form of vector equation and Cartesian equations of a straight line passing through 5, 2, 8. And the straight line is perpendicular to the straight lines. Okay, one straight line and the second straight line is given. Okay, so see now here we are not going to find the shortest distance, but here what is asked? Parametric form of vector equation and Cartesian equation of the straight line passing through 5, 2, 8. And how the straight line, how it is? It is perpendicular to another two given straight lines. Okay, see the rough diagram, roughly I have drawn. So to understand this, so this is the required line. Okay, so in the pink color line is the required line whose equation we have to find. So this required line passing through which point? 5, 2, 8. And what is given that this required line is perpendicular to another two given lines. So the given lines I have taken L1 and L2. You look at your L1 and L2, how it is to the required line? They are perpendicular. Okay, see that from this equation your L1 line is parallel to B vector and your L2 line is parallel to D vector. Okay, so have you understood this? Okay, what we have to do? We have to write the equation of the required line. So to write the equation of the required line in the parametric form or in the Cartesian form, two results are needed. One is either a passing point and a parallel vector, or two passing points is needed. Here in your problem it is given only one passing point. Another one is needed what? You have to find the parallel vector of the required line. So now our need is to find the parallel vector of the required line. Okay, so here from these two lines we don't have any parallel vector. These two vectors are parallel to L1 and L2. So we know that B vector cross D vector, how it is? It is perpendicular to B vector and D vector. Okay, so this B vector cross D vector, how it is? It is parallel to the required line. Okay, the parallel vector of the required line is B vector cross D vector. Okay, so you see that the same thing I have explained here. Given that the required line is perpendicular to two given lines, how is your required line? Is parallel to B vector cross D vector. So B vector has to be, it should be the parallel vector of the first line. Okay, so which is the parallel vector? So the vector written along with the parameter is the parallel vector. So here your b vector is equal to 2i cap minus 2j cap plus k cap. And how is your what is your d vector? D vector has to be taken from the second line, so along with the parameter. So this is the d vector. What is d vector? I cap plus 2j cap plus 2k cap. So now what is needed? So you have to find the b vector cross d vector. How to take the cross product? It is nothing but the determinant. In the first row, what do you have to write? I cap, j cap, k cap. In the second row, the components of b vector. That is 2 minus 2, 1. The third row, you have to write the components of d vector. That is 1, 2, 2. And while you are expanding by r1, you will get this answer. So it will become minus 6i cap minus 3j cap plus 6k cap. Now what you are having about the required line? Already it is given. The required line passes through 5, 2, 8 and your required line is parallel to b vector cross d vector. So one passing point and one parallel vector is there. So we can write the parametric form of the vector equation as r vector is equal to a vector plus t into b vector, that only given in the problem. Now which vector is parallel here? So b vector cross d vector. So that's why I have written here t into b vector cross d vector. So r vector is equal to, which is your a vector? The passing point. So it can be written as a vector. So it will be 5i cap plus 2j cap plus 8k cap plus t into, here what has to be written? The parallel vector. Which is the parallel vector? This is. So minus 6i cap minus 3j cap plus 6k cap, where t belongs to r. Okay. Now you have to find the Cartesian equation. What is the formula? X minus x1 by b1 is equal to y minus y1 by b2 is equal to z minus z1 by b3. So which is your x1, y1, z1? That is a passing point. 5, 2, 8. And b1, b2, b3 are the direction ratios of the parallel vector. So this is the, what is the direction ratios? Minus 6, minus 3, 6. They are the direction ratio. So we have to substitute x minus 5 divided by minus 6, which is equal to y minus 2 divided by minus 3, which is equal to z minus 8 divided by 6. Okay, so we have found the parametric form and Cartesian equation of the straight line. Okay, so come to the sixth problem. Find the parametric form of vector equation of the straight line passing through minus 1, 2, 1. And what is given here? Parallel to the another straight line. Okay, and hence find the shortest distance between the lines. So first, what is asked? Parametric form of vector equation. So Cartesian equation is not asked. So here only the parametric form of vector equation. And also what you have to find? Shortest distance between the lines. Okay, you see the rough diagram. So this is the required line. Okay, so this required line passes through which point? So it is minus 1, 2, 1. So one passing point is here. It is given. And this required line, how it is? It is parallel to the given line. This is the given line. Okay. So given line equation is given. Okay. So here this is the position vector of the passing point of the given line. And the vector along with the parameter is nothing but the parallel vector of the line. So this given line is parallel to which vector? I cap minus 2j cap plus k cap. And this green color line and the pink color line are parallel. So this pink color line is parallel to this vector. So automatically this green color line is also parallel to this vector. Okay, so here you are having one passing point and one parallel vector for the required line. So you can write the parametric form of vector equation of the required line. Okay, you see that given that the required line is parallel to the given line, so required line is also parallel to the parallel vector of the given line. So B vector is equal to I cap minus 2j cap plus k cap. So the required line passing through minus 1, 2, 1 and parallel to I cap minus 2j cap plus k cap. So what is the formula? R vector is equal to A vector plus SB vector. Here in this given line it is used T. So here I have used as S. Okay, SB vector. So A vector, the passing point whose position vector is written here, plus S into your parallel vector is written. So we have found the parametric form of the vector equation of the straight line. Okay, and what is asked? Hence, find the shortest distance between the lines. So what lines? The required line as well as the given line. So I am going to find the shortest distance. So the required line equation, what we have found, I have written as a first line, and this is the given line equation. Okay, how these two lines are? They are parallel. So the shortest distance between the parallel lines, what is the formula? How the line should be? R vector is equal to A vector plus SB vector, and R vector is equal to C vector plus TB vector. If it's so, the distance formula is modulus of C vector minus A vector cross B vector divided by modulus of B vector. Okay, so first we have to arrange the parallel lines. Look at this. See that here I cap minus 2j cap plus k cap, required line, and here also I cap minus 2j cap plus k cap. So therefore the parallel vectors are same. So A vector is a passing position vector of the passing point, the first line. This is your A vector, and this is your, from the second line, this is your C vector, and here this is your B vector. So B vector is equal to I cap minus 2j cap plus k cap. So what is the formula? Modulus of C vector minus A vector cross B vector divided by modulus of B vector. So to find this, what is needed? C vector minus A vector. Okay, how to find this? As C vector is written here, A vector, you have to do the subtraction. So 2 minus of minus, so it will be 3 I cap. So 3j cap minus 2j cap is j cap, minus k cap is minus 2k cap. Okay, so we have found C vector minus A vector. Next, before finding the absolute value, first we have to find the cross product. Here you should not write the modulus. Okay, so here C vector minus A vector cross B vector. So how to evaluate the cross product? It is nothing but the determinant. First row I, j, k cap, and the second row, which one has to be written? The components of the first vector. What is it here? 3, 1, minus 2. And the third row, you have to write the components of B vector. So B vector is 1, minus 2, 1. So by expanding by R1, you will get the answer. You should not divide it by minus. Okay, answer. This will be changed. So here, what is needed here? Absolute value of this vector. So we have to find the modulus of this vector. So how to find the modulus of any vector? It is nothing but square root of minus 3 the whole squared plus minus 5 the whole squared plus minus 7 the whole square. So your answer is square root of 83. So the numerator I have found. What is in the denominator? Modulus of B vector. So this is your B vector. So whose modulus is square root of, so square root of 1 squared plus minus 2 the whole square plus 1 squared. So it will become root 6. So you have to substitute in the formula. So shortest distance between the parallel lines is equal to root 83 by root 6. Thank you, students.